My name is Brooke Jacobs, and I will be doing my presentation on what's in the water. So, have you ever wondered what's really in your drinking water and how we know it's safe to drink? Um, that's basically what the purpose of the What's in the Water experiment is. It just kind of shows a way that chemists can figure out if what drinking water is safe or what water is safe to be drinking water and what's not. Um, So we had to determine what substances are safe to consume and what aren't. And to do that, we used IR and NMR spectroscopy. So IR spectroscopy is infrared spectroscopy. It shows the electrons that aren't affected, and then the increase in the energy of molecular vibration, and then it also determines the functional groups that are present. So then the NMR is nuclear magnetic resonance spectroscopy, and that shows basically the number of the types of hydrogen atoms. So over here, this top one is an IR spectroscopy, um, and then the one down here is the NMR. So basically the IR shows the peaks, and the long peaks are the ones that are present. I'll get more into that, but like these smaller peaks over here aren't present. Like any of these they wouldn't be considered present because they're small. But these two would be. And then over here, just wherever the waves are, um, shows where the hydrogen atoms. And then for the experiment, we had to determine the functional groups that were present. So we had to determine an oxygen if it had a oxygen-hydrogen bond, two different carbon-hydrogen bonds. The first one is on a benzene ring, and the second one is a singly bonded carbon atom to hydrogen. And then a carbon bond double bonded to an oxygen, and then a carbon to a chlorine, and then a carbon to a bromine. So the numbers that are next to each of these are the numbers that you look for on the IR spectroscopy. So if there was a peak that had the number below it that was like 3,500, it would be an OH bond. So then, whatever functional groups are present, that helps you determine what compound it is, and then the NMR determines the ratio. So these are two examples. It's one example from my experiment. So this is from my first unknown sample. So down here, the first red circled, and then the second one. So the first one would be a singly bonded carbon hydrogen bond, and then the second one would be a carbon double bonded to oxygen bond, and then that made that methyl acetate, and then the NMR. You can see the waves down here, and then so basically, these compounds can have effects on the environment and on people. So for humans, they all have really the same skin irritation, and just isn't good to ingest any of these because it can cause coughing, trouble breathing, burning of the eyes, and throat irritation. So basically, that was what's in the water.